Hello, I'm Qian from Apple. Now I'm going to present our research work on ensemble inversion. Model inversion refers to the scenario where, given a predictive machine learning model trained supervised by a training dataset, an attacker abuses their ability to run inference on input of their chosen and obtain corresponding output, attempting to reconstruct the sensitive information of the original training dataset. This attack has attracted increasing research attention because it may impose privacy concerns if the training dataset contains private data, such as images of faces. During model inversion, the trained model under attack is usually frozen and used to guide the training of a generator, such as a generative adversarial network, to reconstruct the distribution of the original training data of that model. However, high-quality reconstruction of the training data based on a single model is challenging because a single model under attack usually only learns the most distinguishable features of the target identity, instead of all recognizable features. However, according to the heat maps of the face images in this slide, different models usually focus on different aspects of a same image. Therefore, it would be beneficial to depend on multiple model under attacks instead of just one to extract more comprehensive information about the target identities. In this area of big data, either individual agents or collaborative learning systems keep generating updated releases of software product for a stable group of users. So it is not difficult for an attacker to collect multiple versions of prediction models trained with target identities, and it is not difficult to estimate the class correspondence between models either. Therefore, they can potentially perform more successful model inversion attack based on these correlated models. In this work, we propose to scale up the standard single model inversion setup and make it involve multiple model under attacks, like this. Here, we refer to a group of correlated models as an ensemble, so the proposed technique is named ensemble inversion. The basic idea is that multiple model under attacks are used to guide the training of the generator, and an optional discriminator can be involved if auxiliary dataset is available. Otherwise, we can also perform data-free experiment without this discriminator. And we can also integrate additional constraints like the one-hot loss and the maximum response loss to encourage the sharpness and the strong activation at the output of the model under attacks. And here are the experimental results for the attack on MNIST digit classifiers. We tried both data-free setup and auxiliary data-based setup, which uses eMNIST letters as auxiliary dataset. To evaluate the model inversion performance, we use attack accuracy of an independent evaluation classifier as a matrix. According to the following result, increasing the number of model under attacks inside Ensemble and applying additional loss terms can lead to both improved visual quality and also improved attack accuracy. And we also performed ensemble inversion on face classifiers trained with VGG Phase 2. According to the visual result of the generated samples and the corresponding attack accuracy, the improvement of ensemble inversion on top of the single model inversion is still noticeable. So in this work, we proposed an ensemble inversion technique which leverages the diversity of an ensemble of machine learning models to boost the model inversion performance. In addition, we introduce additional losses and the sample filtering method, which leads to further improvement on the quality of generated samples. And we hope these results will inspire research on corresponding defense mechanisms against such type of attacks. Please see the paper for more details and additional experimental results. Thank you so much for your attention.